Welcome to today's Explainer. All right, so today we're shining a spotlight on a fascinating, totally unseen world that exists literally right alongside ours. We're looking at a family of viruses that have quietly co-evolved with rodents in the wild for millions of years. Usually, they leave us alone, but when humans accidentally cross paths with them, well, the results can be absolutely devastating. Today, we're talking about hantaviruses, the invisible threat.
Okay, let's jump right into this with a scenario that might hit a little close to home. Imagine it's the first warm weekend of spring. You head out to the countryside to open up a summer cottage, or maybe you're just finally clearing out that dusty old shed in your backyard. You grab a broom, you start sweeping, and a massive cloud of dust fills the air. Could that simple, everyday act be deadly? Well, as we're going to see in the data today, if that dust contains aerosolized droppings from an infected rodent, the answer is a very sobering yes.
And honestly, this quote from our source material perfectly captures the core of the issue. It says, humans do not belong to the natural host range of hantaviruses. An infection generally occurs accidentally by inhalation of virus-containing aerosols from rodent excretions. Basically, the crucial takeaway here is that we aren't the intended target. We are just accidental victims in a biological cycle that has absolutely nothing to do with us. We literally just stumble into a viral crossfire by breathing the wrong air. So to understand how this microscopic threat operates, here's our roadmap for today. 1. The invisible rodent threat. 2. How the virus spreads. 3. A tale of two syndromes. 4. The immune system overreaction. 5. Diagnosis and supportive care. And finally, 6. How to protect yourself.
All right, let's get into Section 1, the invisible rodent threat, a global stealth pathogen.
You know, what's truly astonishing about hantaviruses is just how widespread they are. They're carried by specific rodents, like voles, mice, and rats, that live all across Europe, Asia, and the Americas. To give you a sense of the sheer scale we're talking about here, just look at this number, 100,000. That is the estimated number of hemorrhagic fever with renal syndrome, or HFRS, cases that pop up worldwide every single year. The vast majority of these, like up to 90%, are in China, but thousands of cases also hit across Europe and Russia. So we're not talking about some rare, isolated anomaly. This is a massive, ongoing reality for global public health.
But now, contrast that massive caseload with this staggering figure right here, 40%. That is the estimated mortality rate for the American variant of the disease, which is known as Hantavirus cardiopulmonary syndrome, or HCPS. While HCPS cases over in the Americas are way less common, we're talking around 200 reported annually. The severity is just off the charts. This wild contrast between the high prevalence of the Old World virus and the extreme chilling lethality of the New World virus makes this such a fascinating biological puzzle.
Moving right along to Section 2, how the virus spreads, the spillover event.
So you're probably wondering, how exactly does this virus get from a random mouse in the woods into a human being? Well, in nature, hantaviruses just quietly bounce around between chronically infected natural hosts. The mice or voles don't even get sick, they just carry it. But as they go about their little lives, they shed the virus in their urine, feces, and saliva. The real danger kicks in when those excretions dry out and turn into aerosolized dust particles. When a person walks into that environment and breathes in those microscopic particles, boom, the virus leaps straight into human lungs. And that right there is the spillover.
So who is actually in the crosshairs for this? Really, it all comes down to how close you get to these rodent habitats. People at the highest occupational risk are folks like animal trappers, forestry workers, farmers handling crops, or military personnel out on maneuvers. But everyday activities carry serious risks too, like chopping wood in a dusty shed, or, exactly like we mentioned earlier, sweeping out a poorly ventilated cellar or summer cabin in the autumn.
Let's look at Section 3 now, a tale of two syndromes, kidneys versus lungs.
Once the virus actually breaches the human body, the disease you get depends entirely on which specific hantavirus you inhaled. The whole family effectively splits into two distinct geographically separated diseases. On one side, we have HFRS, caused by Old World viruses in Europe and Asia, like the Pumala or Dabra viruses. These guys primarily attack your renal system, causing kidney failure and hemorrhagic or bleeding symptoms. On the flip side, we have HCPS, caused by New World viruses in the Americas, like the Sin Nombre or Andes viruses. These bypass the kidneys and primarily target the lungs, causing really rapid, severe respiratory failure. It's one family of viruses, but two completely different battlegrounds inside the human body.
Now let's walk through the clinical progression of severe HFRS because it moves incredibly fast. It plays out in 5 very distinct steps. It kicks off with the febrile phase, just an abrupt onset of high fever, chills, and severe aches. Suddenly, the patient drops into the hypotensive phase. Their blood pressure absolutely plummets, shock can set in, and you often see severe internal bleeding. Next up is the terrifying oliguric phase, where kidney function drops off a cliff or stops entirely, causing toxins to just build up in the blood. If they can survive that, they enter the polyuric phase. Kidney function finally recovers and fluid is flushed out in massive amounts. And finally, the convalescent phase, which is a really slow recovery that can take months.
If you trace the kinetics of this infection visually, it reveals a timeline of absolute physiological chaos. Notice how the green viral load line peaks really early, right around the start of the fever. But look at the red line. Those are the platelets. Right as the patient enters those dangerous hypotensive and oliguric phases, blood platelets take a massive plunge. That's exactly what explains the severe bleeding risk. And right at the same time, look at the dark red line for serum creatinine spiking sky high during the oliguric phase. That is a massive distress flare signaling acute kidney failure.
All right, Section 4. The immune system. Overreaction. A double-edged sword.
So what is actually causing all this massive organ failure? To understand that, we have to zoom in a bit. The central biological phenomenon driving the danger in both the lung targeting and the kidney targeting variants boils down to this concept: vascular permeability, or capillary leakage. Basically, the virus messes with the microscopic barriers of our blood vessels. Think of your capillaries normally acting like a solid pipe. Now imagine they suddenly act like a leaky soaker hose in a garden. Fluids begin leaking out of the blood vessels and just flooding the surrounding tissues. This exact leakage is what drowns the lungs in the American HCPS variant, and it's what causes the fatal drop in blood pressure and shock in the Eurasian HFRS variant.
But here's the ultimate plot twist, and honestly, it is totally fascinating. The virus itself, it doesn't actually destroy our blood vessel cells. In fact, it replicates pretty slowly. The real damage is an immune betrayal. As the virus replicates inside the cells, our own immune system detects it and launches a panicked, massive counterattack. It's actually our own T cells and a flood of inflammatory cytokines that end up destroying the capillary walls. Our body's primary defense mechanism essentially becomes a deadly double-edged sword.
Bringing us to Section 5, Diagnosis and Supportive Care, Buying Time. So imagine a patient crashes into the ER with their immune system in complete overdrive and their blood vessels leaking everywhere. What can doctors actually do? Well, early diagnosis is incredibly tricky because the initial phase mimics a standard run-of-the-mill flu, fever, chills, muscle aches. Because of this, specific lab findings are an absolute lifeline. Doctors look for thrombocytopenia, that dangerous drop in platelets we looked at earlier. They look for protein in blood in the urine. And to actually confirm the virus, they have to rely on specific serology tests to spot the antibodies or RT-PCR tests to detect the viral RNA itself.
And because there's no magic bullet cure here, treatment is all about intensive supportive care. Managing the fluid balance is quite literally a matter of life and death. Because the patient's capillaries are leaking like a sieve, critical care doctors are forced to walk a razor-thin tightrope in the ICU. If they give too much IV fluid, it just leaks out and drowns the patient's lungs. But if they don't give enough, the blood pressure crashes and the patient dies of shock. It's a highly delicate minute-by-minute balancing act to just keep the patient alive long enough for their own immune system to calm down.
And finally, Section 6. How to protect yourself, the only defense.
With such a harrowing clinical journey and literally no simple cure available, prevention becomes absolutely paramount. Look at the stark medical reality we're facing today on this chart. Under therapeutics, there are 0 FDA-approved targeted treatments for either syndrome. Antivirals like ribavirin, well, they've shown some very limited success if given incredibly early for the kidney variant, but they have shown 0 clinical benefit for the lung variant. And while a few vaccines are used locally in parts of Asia, there are absolutely no approved vaccines for wide use in the US or Europe. So prevention is essentially our one and only shield. So, what does practical defense actually look like for you and me? It all comes down to changing our behavior around potential rodent habitats. If you're opening up a closed space, like a shed or a cabin, throw open the doors and windows to ventilate it well before you go inside. Never, ever dry sweep a dusty, potentially contaminated floor. Always wet wipe surfaces with disinfectants to keep that dust from going airborne. Keep rodent food sources far away from your living spaces. And hey, if you absolutely must work in a dusty, infested area, wearing a high-quality protective mask is a super simple, highly effective barrier. Which brings us to our final thought for today.
Hantaviruses are an ancient pathogen, sure, but they are highly reactive to their environment. As changing climates continue to alter ecosystems, the geographic distribution and sheer numbers of these rodent hosts are constantly shifting. And that means human encounters with these invisible threats could very well increase. So I'll leave you with this to chew on. As habitats change and rodents move closer and closer to human populations, are we actually prepared for the next spillover? It's a crucial question for the future of public health. Thank you so much for joining me on this deep dive in today's Explainer. Stay curious, stay informed, and I'll see you next time.